So we're now looking at Leaving Cert question 12 part B. It's one of these half questions, 28 marks in total. Very popular question. Should take you maximum about 10 minutes to complete it. So let's have a look at the question in our notes or our physics book. So it says the diagram shows a ray of light as it leaves a rectangular block of glass. As the ray of light leaves the block of glass, it makes an angle theta with the inside surface of the glass block and an angle of 30 degrees when it's in the air as shown. The first thing you need to be careful of here is we always measure angles with respect to the normal. They're not doing that here. So they're trying to trick you a little bit. You got to be a little bit careful. In part 1, they're telling me if the refractive index of the glass is 1.5, calculate the value of theta. Okay, so let's have a look at this in detail. It's not a hard question, but you just need to be a little bit careful. So, first thing I'll do is I'll put my normal in. So there's my normal. So remember, we measure angles with respect to the normal. So if the light is going from glass out into the air, this here is the incident ray. So this here is your angle of incidence I. And your angle of refraction will be, well, it's not 30 degrees, it's 90 minus 30, which is 60 degrees. So be careful about that. They want me to find the angle theta in part 1. 12 marks for this. Look, we'll find I is normal, and then we'll just simply take I away from 90 degrees, because the normal is 90 degrees to the surface, and we'll find theta that way. So how do we do our problems on refractive index? Well, we do them the same way all the time. We write down our entire formula, sine I over sine r is equal to V1 over V2 is equal to lambda 1 over lambda 2 is equal to, remember the refractive indices are turned upside down, N2 over N1. We'll just need two parts of that formula. So what have I got? Well, I want to find the angle of incidence, which is in the glass. So the light is going from glass to air. So in my table, I put glass first, and then I put air. So I is equal to question mark. The angle of refraction in the air, or is equal to 60 degrees. They gave me the refractive index of glass to be 1.5. So Ng is equal to 1.5. And the refractive index in air, well, you always know that automatically that's equal to 1. So I need to use two parts of my 4-part formula. I'm going to use the part involving I and R, and I'm going to use the parts involving refractive indices. So write down my formula, sine I over sine R. And remember, turn these upside down. So it's going to be Na over Ng. Put my numbers in. Sine I over sine 60 is equal to Na1 over Ng 1.5. So I just now have to do some simple maths and solve that for I. You can do it by cross multiplying in your head. So visualize these arrows in your head. Slide the objects along those arrows. So I'm looking to get sine I on its own. That implies sine I is equal to, slide the sine 60 up, sine 60 divided by 1.5. And therefore I would be the inverse sine of that. So I is equal to the inverse sine of sine 60 over 1.5. So put that into my calculator. So I've got shift sine, fraction, sine 60 divided by 1.5. And you be doing these calculators with me. Don't be watching me doing the calculations. And I get, say, 35.26 degrees. And of course, it's not I that are looking for theta. So find theta. Just take that angle I away from 90 degrees. So take 35.26 degrees away from 90. And when I do that, I get 54.74 degrees. How many decimal places should I go to? Doesn't really matter. I'd always go one decimal place anyway. If you want to go two, that's fine. But they never tell you. So it's up to you. They can't penalize you for going one decimal place when the market scheme says two decimal places. So that's the part. Don't be tricked by the theta being an angle that wasn't to the normal. Right, let's go on to the second part of the question. The second part of the question says this. What would be the value of the angle theta? So the ray of light emerges parallel to the side of the block of the glass. You kind of know what they're talking about there, don't you? So what we know they're talking about here is, here's my ray of light going in. There's theta as usual. And this time, the angle of incidence is such that the ray of light doesn't escape. It actually goes along parallel to the edge of the glass. If you go beyond that angle, you get TIR, total internal reflection. So you know what that angle is. That angle is the critical angle C. The first thing you do is, we want to find theta in that situation. First of all, I want to find the critical angle. Write down your formula. My formula is n is equal to 1 over sine C. Let me write down the number of marks which I forgot to do. It's going to be 9 marks for this question altogether. So n is equal to 1 over sine C. Slide the sine C up and the n down. So sine C is equal to 1 over n. And therefore C is the inverse sine of 1 over n. And what's n? Well, we know already that the refractive index of glass is 1.5. They gave me that already. So it's 1 over 1.5. So put that into your calculator. So I've got shift, sine, fraction, 1 over 1.5, close bracket. And I get an answer of, say, 41.81 degrees. As the critical angle. And again, they're talking about theta, aren't they? So don't forget that. So theta will be 90 degrees minus that critical angle, 41.81 degrees. So I get an answer of? I get an answer of 48.19 degrees. Or let's say 48.2 degrees is fine. So there's my angle theta. So let's move on now to the third part of that question, part 3. So the third part of the question says, calculate the speed of light as it passes through the glass. So actually, they're just actually asking me to use my main formula in all kinds of different ways. So there's 7 marks for this question. Calculate the speed of light in glass. Well, there's your main formula again. So I just keep on writing that down. I'm going to keep on using 2 parts of it. So we're going from glass to air, and they're asking me to find the speed of light in glass. Vg equals question mark. We know what the speed of light in air is. You'll get that in your table look. We'll call that VA, which is 3 by 10 to the power of 8. And then, what else will I use? Well, you've got I and or, haven't you? But you've also got the refractive indices. So you're going to use two parts of this formula. So I'm going to use the V1 and V2. I'll probably use the refractive indices because they're a bit easier, aren't they, than the sin I and the sin R, but it doesn't matter. So the refractive index of glass is 1.5, and you know what area is automatically. It's 1. So now apply your formula. So it's going to be V1 over V2, or in this case, VG over VA is equal to, and don't forget to turn them upside down. It's going to be NA over NG. To put my numbers in, VG is what I'm looking for, over VA, which is 3 by 10 to the power of 8, is equal to NA1 over 1.5. So once again, put the arrows in your head, cross multiply, slide the 3 by 10 to the power of 8 up. So VG is equal to 3 by 10 to the power of 8 divided by 1.5. You can actually do that in your head. Divide the 1.5 into 3. And I get 2 by 10 to the power of 8. I'll put the units in when you're finished. Meters per second. So there's the speed of light in glass. Okay, it's a nice question. Tested a lot of things. The one thing we have to be careful of all the time is theta being in the wrong place as such. We remember everything is measured with respect to the normal.